Speaking requires the brain, nerves, muscles, breath, and emotions to work together in real time. Even slight disruptions, too small to notice with the ear, can be captured in the sound waves and language patterns. That makes speech one of the most sensitive, non-invasive windows into neurological and psychiatric conditions. The paper uses the V3 framework to ensure speech biomarkers are valid. Verification. Is the recording clean enough? Analytical validation. Do the numbers we extract from voice actually measure what we think? Clinical validation. Do those numbers match real health outcomes, like memory loss or depression severity? This stepwise approach is how science moves from theory to reliable practice. Verification means testing the basics, different voices, background noise levels, and recording design. Research shows smartphones can capture clinical quality recordings if conditions are controlled. This opens the door to at-home monitoring that's still scientifically rigorous. This is the science of turning raw audio into health data. Acoustic features include pitch, jitter, shimmer, and MFCCs. Linguistic features include vocabulary richness, sentence complexity, pauses, error, and sentiment. Together, they create a high-dimensional health profile, far richer than a questionnaire. The final step is proving that the signals correspond to clinical outcomes. Research shows Alzheimer's and mild cognitive impairment. Language patterns and fluencies predict decline years before traditional tests. Parkinson's. Vocal changes often appear before motor symptoms. Depression. Slowed and flat speech is measurable. Schizophrenia. Disorganized language can be quantified. These findings prove speech biomarkers reflect disease processes. Case studies and longitudinal research strengthen the evidence. Subtle shifts in language detected years before Alzheimer's diagnosis. Early writing complexity predicting dementia in the Nun study. And simple sustained vowel sounds revealing Parkinson's decline. This suggests speech could be a universal biomarker of brain health. The science also highlights risks, bias across demographics, noise effects, and algorithm drift. That's why ongoing evaluation, transparency, and human oversight are critical. This framework is exactly what we apply in the alignment assessment. We use verification, guided noise checks and calibration, analytical validation, combining acoustic and linguistic features, clinical validation, tracking changes in stress, energy, and cognition. Our approach takes the recommendations of this white paper and makes rigorous science practical and accessible.